and powerful things in the entire universe. Today I'm just going to be doing a short video on a part of what is in my new book that I'm writing about black holes. So, I'm not going to say all the weird stuff that happened for humans to discover these behemoths of power, but I will start off with the beginning of the life of a black hole. Before I start, I should say that we don't know everything about black holes, and some of this might turn out to be wrong in future years, or in this year, because even though I went to a lot of sources, a few of them could have been wrong, and I could have just messed up. So, I'm sure a few of you guys know that after a star dies, it collapses into a neutron star, a white dwarf, or a black hole. Depending on the mass of the star, the black hole could form. It could be very it could be like the size of a penny to an atom or to a galaxy, and yeah, possibly even bigger. They're really large. For an example, let's use our planet Earth. If we were able to collapse our planet into a black hole, then it would have a diameter of 1.775 centimeters. That's about the diameter of a size 15 ring for any of you married people out there, because I'm not. Meaning that it would take an enormous amount of mass to make a black hole bigger than our sun. And yet, there are many that have completely passed this threshold entirely. I mean, like, there are ones that are bigger than our entire galaxy. It's pretty insane to wrap your head around. During a black hole's life, all it tries to do is eat things. Eat materials, stars, planets, space dust, anything like that. So, yeah, that's pretty much all that it does. It does this with the intense mass that can be measured as pretty much infinite when it turns into a black hole. Yeah! The size of the event singularity, or the singularity, which is the point of all mass in a black hole, is Planck's length, or 1.6 times 10 to the negative 35th meters. This states that it has the smallest diameter possible, meaning that it's the smallest that anything can be. Smaller than a black hole, smaller than an atom, smaller than a quark, smaller than anything like that. Anyway, back to the life cycle of the black hole or anything, whatever I'm talking about. The idea of a black hole or wormhole came from the theory of relativity, found by Albert Einstein. When or if a black hole collects enough mass and matter, then it grows to fit the new information. That means that the singularity slowly gets bigger. Very, very, very shortly. Like, it takes a lot of mass to do that. Over time, a black hole will start to develop an accretion disk, which is basically a bunch of plasma, as you can see in the picture, that forms around the black hole. This is all just the stuff that it's sucking in, and it's really, really hot. Like, really hot. It can light up an entire galaxy. So, yeah, that's kind of scary. Anyway, and the accretion disk is being superheated because of the gravity of the black hole. After a while, let's say after there are no more stars yeah, that's kind of dark, sorry. After all the stars go out, which I can talk about in a future video, I suppose, the black hole will start to disappear. This is because of Hawking radiation. As an oversimplification, because this is a very mathematical and large principle, I'm just going to say a black hole basically just erodes over time, very, very small, like amounts at a time. As it gets smaller and smaller, the erosion happens quicker and quicker, and this is all because of quantum particles that might or might not exist. It's really confusing. Anyway, so I'm sure you guys are wondering, where does the mass and matter go? Well, we don't really know, because... You know what? I don't even have a good reason for that. So that's the end of my brief summary on a black hole. If you guys want to hear more of these things from some of my books that I've been writing, Be sure to like and subscribe, and see you guys next time.